Induction motors are employed mostly because of less cost, rugged construction, good starting torques and very less maintenance. Synchronous motors are rarely used in industries for drive applications. They are generally used as power factor correction device. In industries, they are employed to improve the power factor of the system. The advantages of synchronous motors include constant speed, power factor control, and high starting torque. Synchronous motors are a type of AC motor that operate at a fixed speed. They are commonly used in industrial applications such as pumps, compressors, and generators. Synchronous motors have several advantages and disadvantages. Let's talk about advantages. Power factor control. Synchronous motors can control the power factor. An overexcited synchronous motor can have a leading power factor and can operate in parallel with induction motors and other lagging power factor loads, thereby improving the system power factor. Constant speed. The speed of synchronous motors remains constant irrespective of the loads. This characteristic is useful in industrial drives where constant speed is required. High efficiency. Synchronous motors are highly efficient at converting electrical energy into mechanical energy. Low maintenance. Synchronous motors have a simple and robust design, which makes them easy to maintain. Suitable for high-performance applications. Synchronous motors are commonly used in applications requiring high performance, precision, and stability. Construction and working principle. The construction of a synchronous motor is similar to that of a three-phase induction motor, except that DC is supplied to the rotor. The stator is the stationary part of the motor, consisting of stator poles and windings, which produce a rotating magnetic field when connected to an AC power supply. The rotor is the rotating part of the motor that comprises rotor poles, which can be either wound or made of permanent magnets. When the rotor poles are aligned with the stator's magnetic field, a torque is generated, causing the rotor to rotate and drive the mechanical load. Advantage or merits. One of the major advantages of using synchronous motor is the ability to control the power factor. An overexcited synchronous motor can have leading power factor and can be operated in parallel to induction motors and other lagging power factor loads, thereby improving the system power factor. Synchronous motors can be constructed with wider air gaps than induction motors, which makes these motors mechanically more stable. In synchronous motor, the speed remains constant irrespective of the loads. This characteristic helps in industrial drives where constant speed is required irrespective of the load it is driving. It also useful when the motor is required to drive another alternator to supply at a different frequency as in frequency changes. In synchronous motors, electromagnetic power varies linearly with the voltage. Synchronous motors usually operate with higher efficiencies, more than 90%, especially in low-speed and unity power factor applications, compared to induction motors. Advantages of synchronous motor. The power factor can be controlled easily. The motor can work at lagging, unity, and leading power factors. An overexcited synchronous motor works as a synchronous condenser when connected in parallel with a load having a lagging power factor, which improves the power factor of the combined load. The speed is constant and irrespective of the load. Disadvantages. External excitation requirement. Synchronous motors require an external excitation source to generate a magnetic field. Limited speed range. Synchronous motors have a limited speed range and cannot be used in applications that require variable speed. High cost. Synchronous motors are more expensive than other types of motors due to their complex design. Starting issues. Synchronous motors are inherently not self-starting and need some arrangement for their starting and synchronizing. Maintenance. Collector rings and brushes are required, resulting in an increase in maintenance. These factors should be considered when selecting a motor for a specific application. Disadvantages of synchronous motor. Synchronous motors have some disadvantages as well, which are given below. Synchronous motors are not self-starting. Synchronous motors require DC excitation at the rotor. The construction of a synchronous motor is more complicated than induction motors. Synchronous motors are costlier than induction motors. It is not self-starting and needs some arrangement for starting and synchronizing the motor. It requires separate DC excitation. The initial cost is very high. It cannot be used for variable speed jobs. If the motor is overload, it may fall out of synchronism and stop. It has a tendency to hunt. Synchronous motors have several advantages and disadvantages that should be considered when selecting a motor for a specific application. They are highly efficient, offer high torque, and have a constant speed, which makes them ideal for certain applications. However, they are more expensive, have a limited speed range, and require external excitation. Synchronous motor in industrial applications and future prospects. A synchronous motor is an alternating current AC motor where the rotation of the rotor is synchronized with the frequency of the supply current. This means that the rotation period of the rotor is equal to the rotating field of the machine it is inside of. Synchronous motors are a type of AC motor that operates at a constant speed, known as synchronous speed, which is directly proportional to the frequency of the AC phase supply and the number of poles in the motor. Industrial applications. Synchronous motors find extensive applications in various industries due to their unique properties. They are widely used in industries such as paper and pulp, metal, cement, and chemicals. They are also commonly used in pumps, compressors, fans, extruders, and mills. In addition, synchronous motors are used where constant speed is required, such as in centrifugal pumps, blowers, line shafts, motor generator sets, synchronous clocks, air compressors, textile mills, paper mills, cement mills, etc. Future prospects. The future of the synchronous motors market looks promising, fueled by ongoing technological advancements, increasing demand for energy-efficient motor solutions, and the transition towards electrification and renewable energy. The synchronous motor market is witnessing significant growth driven by the demand for energy-efficient, high-performance motors across industries. Technological advancements, particularly in digital control systems and materials, are enhancing the capabilities of synchronous motors, making them more appealing to a wide range of applications. Moreover, the growing concerns for environmental safety and CO2 emissions have shifted the attention of people towards using renewable and clean energy sources. Owing to this, the electric vehicle demand has grown significantly in different regions. The synchronous motors are being adopted by various manufacturers involved in the electric vehicle market over the conventional induction motors. In conclusion, synchronous motors, with their high efficiency and constant speed operation, are poised to play a significant role in the future of industrial applications and renewable energy projects.